Hi, welcome to Unit 2 of SAT Math, Heart of Algebra Part 1. Let's start off by solving linear equations. To solve for a variable, get the variable by itself using SADMAP, or the reverse of PEMDAS. PEMDAS, of course, being parentheticals, exponents, multiplication, division, addition, and subtraction. So to reverse an operation, all we gotta do is the opposite operation. So for addition, we do subtraction, multiplication, we do division, and etc. Looking at this example, we have x minus 2 equals 5. So in order to isolate x, we want to get rid of that negative 2 by adding 2 to both sides. So getting rid of this negative 2, we add 2 to both sides, and we're left with x minus 2 plus 2 equals 5 plus 2. Simplifying, of course, we see that x is equal to 7. Question 1. 12x plus 2 is equal to 8x minus 8. First step we want to do, let's isolate the x by subtracting 8x from both sides. So we have 12x plus 2 minus 8x is equal to 8x minus 8 minus 8x. Now simplifying, we see that we have 4x plus 2 is equal to no x's left, just negative 8. So now isolating the constants, we're going to subtract 2 from both sides. So we have 4x plus 2 minus 2 is equal to negative 8 minus 2. Simplifying, we see that we've just left with 4x on the left and negative 10 on the right, which means that x is equal to negative 2.5, or negative 2.5b. Question 2. 4 plus 8a is equal to 5a plus 2 plus 3a, and we're asked what is the solution set to this equation. So let's first simplify it. We are going to go ahead and simplify some math quick. So we're left with 4 plus 8a, and we're simplifying by adding the two a components on the right. So we're left with a on the right as well, plus 2. So now let's subtract 8a from both sides. 4 plus 8a minus 8a is equal to 8a plus 2 minus 8a. And see, after doing that, we're left with just 4 on the left, and actually just 2 on the right as well. And we see that 4 can never equal 2, so this equation has no solutions. Question 3. 5 is equal to negative x plus 33, and given this equation, what is the value of this expression right here? So let's first go ahead and solve for x in this original equation by isolating the x components and isolating the constants. So we have 5 minus x plus 33. So let's go ahead and add x to both sides so we get it to be positive. So we have 5 plus x is equal to negative x plus 33 plus x. So this leaves us with 5 plus x is equal to just 33. And now subtracting 5 from both sides, we get that x is equal to 28. So now with that, we can plug it into this expression here. So we have 1 plus 3 times 67 minus 28. So now, doing a little bit more of simplification, we see that we have 1 plus 3 times 39. Simplifying this more, we end up seeing that we get 118 just by doing some algebra there. So we get D. Okay, 4 has z plus 1 to the 3 halves power is equal to 1 over 216 to the 1 half power. So in order to get rid of that 1 half, or that square root in the exponent on both sides, let's go ahead and square both sides. Once we square both sides, we have z plus 1 to the third power is equal to 1 over 216 to the first power. So now to get rid of that cube on the left-hand side, let's go ahead and cube root both sides. So now we have z plus 1 to the first power is equal to 1 over 216 to the 1/3 power, which is the same thing as 1 over 6. So now isolating z, we have z is equal to 1/6 minus 1, the same thing as negative 5/6, or c. Now, solving linear inequalities. You treat inequalities the exact same way you treat equations, except when you multiply or divide both sides by a negative, you have to reverse the sign. So let's see the example. Negative 2x is greater than negative 24. So when we divide both sides by negative 2, we see that we have x on the left as we would expect, and 12 on the right as we would expect, except we have to reverse this greater than sign, so now it's a less than sign. Okay, problem 5. We have 3x plus 5 is less than 3x plus 2. And we're asked to see which of the following solutions best describes the inequality. So let's go ahead and isolate the x by subtracting 3x from both sides. So now we have 3x plus 5 minus 3x is less than 3x plus 2 minus 3x. Simplifying, we see that we have 5 is less than 2. We know this to never be the case, so if there's a problem, there's no solution. D. Problem 6. If 2 is greater than 3x plus 1, which of the following is the range of values for 12x plus 4? So the simple way to do this would be to just see what the relationship between 3x plus 1 and 12x plus 4 is. So we kind of minimize the number of steps we have to do. Otherwise, we would have to isolate x and then try to make it 12x plus 4. But if we see 3x plus 1 is actually just 1/3 of 12x plus 4. So let's go ahead and take this expression right here and multiply it by 4. So we have 2 times 4 is greater than 4 times 3x plus 1. So now simplifying, we have 8 is greater than 12x plus 4. So now we see 12x plus 4 is the same as above here, and we see that it has to be less than 8. So we see D is the correct answer. Question 7. If 6ax minus 12 is greater than 22, where a is a positive constant, which of the following describes all possible values of 6 minus 3ax? So first thing we want to see is how can we relate this expression to get it more like this expression, right? So if we have 6ax minus 12 is greater than 22, the first step we could take to try and make it look like this would be to multiply both sides by -1. Doing that means we would get 12 minus 6ax now, multiplying both of those by -1, but we also have to remember to flip the sign. So now we have less than -22. Now, one step between this expression we currently have and what we're looking for is just dividing by 2. So there, to do that, we have 6 minus 3ax is less than -11. So it means we can pick a, any value less than -11. Okay, interpreting linear functions. The coefficient shows incremental change. The constant shows the starting point. So for example, for an equation like this, we have, it starts at 3. So when x equals 0, y equals 3. And when x increases by 1, a unit change, y increases by 5. The 5 is right here, how much y changes for every one change in x. And the 3 is here for where it starts. So question 8. T is equal to 11m plus 40. Tom decides to cook a turkey. The interior temperature T of the turkey in degrees Celsius after cooking for m minutes is given in the equation above. Which of the following statements is the best interpretation of the number 11 in the context of this problem? So based on what we just learned, 11 is the number that goes in front of our independent variable, m here, which means that for every one change in m, a unit change in m, which is 1 extra minute cooked, we're going to see 11 change in T, which is equivalent to 11 degrees increase in T, which means for this one, we're going to pick B. The interior temperature of the turkey increases by 11 degrees for every additional minute that it's cooked. Okay, question 9. The equation above is true if Amy buys B number of blue skirts and R number of red skirts at a department store, where blue skirts cost $11 per skirt, so we see that $11 for every blue skirt, and red skirts cost $12 per skirt, so $12 for every red skirt. According to the equation, how much does Amy spend in total on both types of skirts? So clearly, if we're multiplying 11 for every blue skirt and 12 for every red skirt here, we see that what this equation really shows us is how much we're really spending. So however many blue skirts she buys, however many red skirts she buys, ends up totaling $56. So 56 is our answer here. Question 10. The annual electricity bill, C, in dollars for a football stadium using N solar panels is given by the equation above. What is the best interpretation of 144 in the equation above? 144 is here. So let's see how this kind of relates to our independent variable, N. What happens when N is equal to 144? When it's equal to 144, we actually get C to be equal to 0, which means when our number of solar panels is 144, like they're asking for, our electricity bill is actually going to be equal to 0. Because if N is equal to 144, this right here is 0, so C is equal to 0. Electricity bill is $0 when our stadium uses 144 solar panels. Okay, question 11. The number N of cars in San Diego, Y years after January 1st, 2000, is given by the equation above. What is the best interpretation of 3,788 as shown in the equation? So we see that 145 is our incremental change, 3,788 is our starting point. So if we're looking for the best interpretation of 3,788, that's going to be our starting point, which we know to be on January 1st, 2000. So number of cars were 3,788 in the city on January 1st, 2000, or B in this case. Question 12. Tiffany has decided to purchase a new house. Tiffany's total payment I in dollars in the first J months satisfies the equation above. How much did the initial down payment cost? So if we look at our equation, 5I minus 15,000J equals 90,000, it isn't quite in the form that we're familiar with. So let's rearrange. How? We are looking for the initial down payment cost, which means we are looking for I, the total cost, when J is equal to 0, so the initial cost. So let's go ahead and rearrange so we can put it in terms of I. So let's first, from this equation, let's go ahead and add 15,000J to both sides. So we have 5I is equal to 15,000J plus 90,000. Now, let's divide both sides by 5. We have I is equal to 3,000J plus 18,000. So now we see when J equals 0, our initial cost is 18,000, or A. Okay, now let's look at translating algebraic expressions. So go from words to math. So if we say something like a number or an integer, we'll just denote it as some x. If we're looking for consecutive integers, saying we're starting at some x, we have x, x plus 1, x plus 2, and so on. If we're looking for consecutive odd numbers or even numbers, we start at some x, and then we have x plus 2, x plus 4, x plus 6, where all of those are going to be either all odd or all even. And if we have to say something like integers is or equals, we'll have an equal sign. If we say something like greater than, sum, or total, an addition sign. If something like less than or difference, it's a minus sign. If we say something like of or product, it's a multiplication sign. Say something like quotient, it's a division sign. Make note here that 5 less than x, it means x minus 5 here, not 5 minus x. It's a different thing. So 13. A recently renovated inn charges $50 per day for a single occupied room. The inn has a total of 150 rooms. So how much money D does the inn make per day if they have V vacant rooms? So let's start off with the maximum amount they could possibly make. That's going to be 150 rooms, and they're all booked for $50 per day. So 150 times 50. So now let's subtract the vacant rooms, the ones they don't make money for. So those we would have overcounted by V rooms multiplied by $50 per room. So this is equal to the amount we make per day, D. So here we can do a little bit of manipulation and factor out a 50. So we have D is equal to 50 times 150 minus V, and we see that this is equal to A. Question 14. Jenny and Bao work at a restaurant. Jenny works 5 hours more per week than Bao does. In a given week, they do not work for more than a combined total of 16 hours. If X is the number of hours that Bao works, which inequality best models this situation? So let's go ahead and start by calling the number of hours Jenny works J and the number of hours that Bao works B. So let's translate this first sentence first. Jenny works 5 hours more per week than Bao does. So that means that J should be equal to B plus 5. So Jenny works 5 more hours than Bao does. Now, this sentence here, they do not work for more than a combined total of 16 hours. That means B plus J should be less than or equal to 16. Now, since we're looking for the number of hours that Bao works, which they call X, we call B, we'll switch it in a sec. We want this expression in terms of B. So let's substitute the expression we found for J into this second equation. So we get B plus 5 is less than or equal to 16. Simplifying this, we get 2B plus 5 is less than or equal to 16. Of course, they call it X. It's a pretty easy substitution. We see that A is the correct answer. Okay, for linear equation word problems, we have when 6 multiplied by the number n is added to negative 10, the answer is 8. When this same number n is multiplied by 3 and added to 7, what is the result? So let's go ahead and translate this first sentence first. 6 multiplied by the number n, that's just 6n, added to negative 10, so we add it to negative 10, we should get 8. So we get 8. So now, isolating 6n by subtracting negative 10, we have 6n should be equal to 8 minus negative 10. Simplifying and dividing both sides by 6, we see that n is equal to 8 minus negative 10. 18 divided by 6 is 3. So now, second part, n is multiplied by 3 and added to 7. So multiplied by 3, that's 3n, added to 7 plus 7, what is the result? That's what we're looking for. So we're going to plug n equals 3 in here. So that's 3 times 3 plus 7. And we see that is equal to 16. We get B is our answer. Okay. In Los Angeles, the property taxes decrease as the distance from the town hall increases. The largest property taxes are located right next to the town hall at 4.5%. Every 10 miles away from the town hall, property taxes lower by 0.5%. A certain house's property tax is 3%. How far is that house from the town hall? So we are looking for house property tax of 3%. So that's what we're looking for. So that should be equal to this calculation for the percentage to property tax that we're given. So we see that right next to the town hall, we have 4.5, right? So that means our initial value and our x is equal to 0 miles away, we have 4.5. But from there, we keep getting smaller and smaller as we get further away. What happens is they lower by 0.5% every 10 miles. 0.5 is kind of like our slope, our incremental change. So 0.5. But it's not 0.5 for every mile. It's 0.5 for every 10 miles. So if x is the number of miles away, we're talking about x over 10. So for every 10 miles, we drop by 0.5. So here, now, if we go ahead and do a little bit of isolation of our variable x, we see that we can solve for x being equal to 30 miles away, or C. Question 17. Last year, Jim's income tax turned out to be $3,450. He was taxed 10% for the first $20,000 he made and 20% for all income greater than $20,000. Which equation best models D, Jim's income in dollars? So, first of all, let's set up the equation here. We see his income tax turned out to be $3,450. So let's write that on one side of the equation. Now, we know that he was taxed 10% for the first $20,000. So that means 10% of the first $20,000. Then we also know that he was taxed 20% on top of everything above 20,000. So it's 20% of everything above 20,000, which is D, the total amount he made, minus 20,000. So now we see this is the first 10% taxed, and this is the 20% taxed of everything he made above $20,000, and this should be equal to $3,450. So we see that this is going to be answer choice B. Okay, question 18. A limousine rental company charges a one-time fee of $400 along with a charge of 50 cents per mile. John will rent a vehicle at this company, but he has a $575 budget. Which of the following is a possible number of miles that John can drive without exceeding his budget? So again, let's set up the equation. First off, we have a one-time fee of $400. So that's just a flat $400. And then we add 50 cents per mile. So let's call the number of miles he drives X. That's going to be 0.5 X. And that needs to be less than or equal to his budget of $575. Less than or equal to $575. So first thing we do to simplify, let's go ahead and subtract 400 from both sides. So we're left with 0.5x. It's less than or equal to 175. Now, of course, we divide both sides by 0.5, and we're left with x is less than or equal to 350 miles. So we select answer choice A. Okay, question 19. Ari is planning a bake sale to raise money for the local shelter. The cost C of the baked goods B is given by C equals 4B. The cost of renting tables is $100, and Aria is planning on selling each baked good for $6. What is the range of baked goods that she could sell to make at least $100 to donate to the local shelter? So, setting up the equation, we have revenue minus cost should be our profit. So, we know that our revenue is 6B, which is how much she makes for each baked good that she sells, and her first cost is how much it costs her to make it, 4B, so minus 4B, and then minus the one-time fee of $100 for renting tables. And we want this to basically be greater than or equal to $100 because she wants to donate at least $100. So simplifying this, we see that we get 2B is greater than or equal to, adding 100 to both sides, 200. So this means B has to be greater than or equal to $100. Our answer choice